Good morning, class. This is 4.1 rate of change, and let's just jump into it. Rate of change is a measurement of, well, the most common term is slope, so we're going to stick with slope. Other names for rate of change is steepness. That one's a little less common. Pitch. Or grade. Sometimes gradient. However, slope is going to be the most common that you'll hear throughout math. The grids below show the cross section of 3 roofs. Which roof looks the steepest? So just looking at them, which one do you think is the steepest? 1, 2, or 3, and they're each labeled 1, 2, and 3. And which one do you think is the steepest? If you said number 1, you're correct. Which roof looks the least steep? So which one's the least steep? Well, it's not number 1. If you said number 2, you are correct. So for part C, I'm going to have you complete the table. Determine the rise and run by counting the number of squares. So for roof 1, let's count the run first, because I usually do the horizontal. Well, let's do the rise first in this case, because it's going to get tricky if we do the run first and mess up. So along the dashed line, you need to count out the squares. So if you count them out as you go down, how many do you get for the rise? Rise is up and down. That's your vertical. Your run, so horizontal. And we're only counting from one of the sides to the midpoint for the run. That's how you get rise over run. So we have it rise is 11 if you count them out. If you count the squares horizontally, you should get 5. So the rise over run, you're just going to punch in the numbers into your fraction. Get 11 over 5. As a decimal, this looks like 2.2. And you do that by putting 11 divided by 5. And that'll give you your decimal. For question 2, I'll do another dashed line as we go down here. And then a solid line for the horizontal here. Okay, what's our rise? You count the number of squares from the top point all the way down to the bottom. You should have 5. 5 is our rise. And our run, along the solid line, I see 1, 2, 3, 4, 5, 6, 7, 8. So it should be 8. So our rise over run, well, our rise is 5 over our run, which is 8. So it should be 5 over 8. As a decimal, this should be 0.625. So our decimal is 0.625. Okay, same idea for number 3. You're going to keep going. Oh, my last dash didn't show up. There we go. Then we count out the number of squares. 1, 2, 3, 4, 5. So our rise is 5. Count the number of squares for the run. 1, 2, 3, 4, 5, 6. So our run is 6. And then we put rise over run, so 5 over 6. It's getting very difficult to write down there. 0.83. There you go. So 5 over 6, or 0.83 as a decimal. Perfect. All right, I'm going to go to the next slide. The greater the change, the greater or the steeper the line. So the greater the change, the steeper the line will be. Example 2, we have write each fraction in lowest terms. Remember, with your calculator, you could use that ABC button. If you have one at home, it's the ABC. Looks something like that. So if you did 6 ABC 12, it'll give you it in lowest terms. Or if you don't have that, you have to determine what your greatest common factor between 6 and 12 is. Well, the greatest common factor is actually 6. So if you divide both by 6, 6 divided by 6 gives us 1. 12 divided by 6 gives us 2. Same idea with over here. What's the greatest common what's our greatest common factor for 8 and 4? Well, we would divide both by 4, because 4 can go into both 4 and 8, and you get 2 over 1. Wonderful. Next example, we have 9 over 15. Oh, sorry. Before I move on to the next example, we have to set this as a whole number, which is just 2, because 2 divided by 1 is just 2. Any fraction that's over 1 is just the numerator. So now we have 9 over 15. Well, our greatest common factor is 3, because 3 can go into both 9 and 15. Divide both by 3. You should get 3 over 5. This is review from Unit 1, so I'm not going to go too in-depth with that. Remember to use your ABC button. That should help you out with fractions. So on the grid below, I'm going to use different colors for this. I'm going to use this, where we're going to draw line segments using the rate of change. So I'm just going to start right here. I'm using red for A. And it rises 5, but it runs 2. So I'm going to run 2 first, and then I'm going to rise 5. 1, 2, 3, 4, 5. Perfect. And then you draw a line straight through. And that is a rate of change there. For example B here, we have 3, negative 5. So I'm actually going to give myself a bit of space, extra space over here. I'm going to start B right about here. And I'm going to go left 5 because it's negative 5. So I have to go 1, 2, 3, 4, 5. And then I have to go up 3. 1, 2, 3. I actually ended up right at the very top there. And this is B. Of course, use a ruler if you're doing this. I don't have a way to do this in a live presentation like this, besides using just a line tool. Next example, I'll use blue. So for question C here, I have just 4. So for C, I'm actually going to start way down here. 4 is really just equal to 4 over 1, right? Then we have our rise over our run again, just like we did in the past. So we rise 4, we run 1. I'm going to run 1 first, and then 1, 2, 3, 4. Okay, I'm back now. I'm going to raise this up here. Put a line through it. Perfect. Okay. So that's the end of example 3. Let's move on to the next one. Below shows the rise and run of a wave. Scientists have found a way to wave breaks. What's the rate of change? That is 2 to 7. Determine whether or not the wave is about to break. So we're going to need 2 decimal forms for this. The wave will be about to break if it's at a ratio of 2 to 7. So 2 divided by 7, which equals 0.2857. So if it's 0.2857 or greater, it is about to break. So the ratio of this wave is it has a rise of 0.5 meter and a run of 2.8 meters. So we have a rise of 0.5 over a run of 2.8, which is just equal to 0.1786. Therefore, the wave is not about to break. About to break. So next we're going to move on to example 5. You can pause the video just so that you have enough time to do this. Example 5, plot the following pair of points, join them, determine the rate of change for each line segment. Answer must be in lowest terms. So this is a strategy we're going to teach you. It's very, very short and quick. G. So you know how to plot these points. I'm going to change the color back to red to start for G. Or for A here, I'm going to use red. So I have -2, +5, so 1, 2, 3, 4, 5 right here. And my next point is -3, +9, so right here. There it is. And then I just count the rise over the run. Well, the rise or the run is just 1. Then it's down 1, 2, 3, 4. So the run is -4 over 1, which just equals -4. Sorry, the rise is -4 because we're going down 4 and we're going over 1. So you count how many squares you went over and then how many squares you went down or up. If you go down, it's negative. If you go up, it's positive. So you're reading from left to right to do this. Next example, I'm going to need 4 different colors. I think yellow is a little bit hard to read. Let's try green, blue, and then maybe purple if we need it. So we got green here. M is 3, 2. So the point 3, 2 over 3 up 2. And then 5, 7. So over 5 up 7. Right here. So now we count how many over we went. Well, we went 1, 2 over. So our run was 2. How many did we go up? 1, 2, 3, 4, 5. So it's 5 over 2, which is just 2.5 if you want to leave it as a decimal. Our next example, we have 3, -3, and 6, -3. But before I do that, I got to change my pen color. I'll pick blue this time. Okay, so blue for this. So at +3, -3, right there. And then +6, -3 right here. We have a line that goes across this way. And our run is 1, 2, 3. And our rise, well, it doesn't go up at all, so it's 0. 0 over 3, which is just 0. Whenever your rate of change is 0, that means it's a horizontal line. And look at that, it's a horizontal line. It goes from point I to point J, and it doesn't go up or down at all. Our next example, I'll use, let's go with purple. Actually, let's go with black. Let's use black ink. We haven't done that yet. So we have black ink here. We have the point 6, 1. So at 6, +1, that's our first point. And then the second point is 6, +5. Okay. So there is our line there. And our run is 0 because it doesn't go left or right at all. And it goes up 4. Now, if you try to divide 4 by 0, you get undefined. Sometimes if you use your calculator to calculate this, you'll get an error, but we call it just undefined. And whenever a rate of change is undefined, that means it's a vertical line. So that's a special case there. Those last two are special cases. Okay, let's go on to the next page. You can pause it and copy down what you need. A line segment that rises to the right has a positive rate of change, just like what's outlined over on the right there. A line segment that falls to the right, so as it goes from left to right. If it goes down, it is negative. And if the rate of change of a horizontal line is 0, if it's horizontal, the rate of change is 0. And if it's vertical, it's undefined. The rate of change is undefined. Excellent. Let's finish this up. The rate of change of the line segment falls to the right can be calculated 2 different ways. Calculate the rate of change shown. You can calculate rate of change in 2 different ways. In this case, we actually calculated run as a positive. So we went over 2 and then down 5, which is negative 5. So then you end up with negative 5 over 2. Okay, and this is in proper form because we have a negative numerator and positive denominator. Another way you could calculate this is you could say, well, I went back 2, but I also went up 5. So this would look like 5 over negative 2. If you were to convert both of these into decimals, you would end up with negative 2.5. So these are essentially the exact same numbers. Is one more correct than the other? No, not really. I like the notation of the negative number being in the numerator, just because it makes further calculations easier as you get into later grades, but you guys don't need to worry about that. So those are the 2 different ways you can calculate rate of change. All right, that should be everything for this week. Best of luck. If you have questions, you can always email me. I can set up a Google Classroom if needed, or a Google Meet if needed. And make sure you complete everything.